All right, here we go. We are doing a lesson on special triangle names. Woohoo! Yep, we have classifications, types of triangles, and hopefully you know most of these names. Let me bring down Mr. Piazzolla. All right, first one is a side classification. This is pronounced scalene, and it means it's a triangle with get my red pen here. No sides equal to each other. All right. So, for example, a triangle with sides. This is a really famous scalene triangle, 3, 4, and 5. We'll talk more about that triangle later on. What type of triangle else it might be. Okay. Isosceles, also a classification of sides. Quite a few things here in this type of triangle. Number one, it has at least 2 equal sides. So, for example, a triangle with sides 3, 3, and 5. That's an isosceles triangle. Number one, it's got legs. The 2 equal sides are referred to as the legs. It also has base angles. And the base angles are, and it's got a vertex angle. Let me draw a picture over here because it's a little hard to describe that in words without getting really complex. Most isosceles triangles are drawn kind of in this fashion, with the base here, the legs here, standing up, and the base angles sitting there. Okay? So the base angles are attached to the base. To the base and the leg. And the vertex angle is sitting up here. All right. That's by far the most complex of the triangle names that we have. Next, equilateral triangles. Equilateral triangles are triangles, again classified by sides, with all sides equal. Now, this raises a side point. That is, if all the sides are equal in a triangle, say you have a triangle that is 4, 4, and 4, not only are the sides equal, but the angles are also equal. So write this down next to it, because if you're talking about the angles, didn't spell that right, angular, still don't have it right, better look it up. Oh, there's an I and an A, I guess, in there. Equiangular. All right, this is classifying it not by sides, but by angles. All right. So, again, if a triangle is equilateral, then it is equiangular. I forgot to put in there, sides are equal. All right, and this was angles. We better highlight that in red so we know the difference between them. All right, equiangular and equilateral triangles. Classification, by the way, if the 3 angles have to add up to 180, there's only one way to get equiangular triangles in terms of their angles, and that is that each angle be 60. Acute. You may think they look pretty, but when we say acute, they are a triangle classified by angle, so we're not talking about the sides anymore, with one angle, with all angles, all angles less than 90. Okay, so for example, a triangle that is 50, 60, and 70. All right, is an acute triangle. A right triangle is a triangle with, we have one 90-degree angle. And I'll list it here again. The most famous right triangle is a scalene triangle, 3, 4, 5. There are many others we could list out by sides. We typically don't list them out by angles. Know that though one of them has to be 90, the other two could be anything it wants to. As long as those two, call it angle A and B, those two would have to add up to 90, yeah? A plus B. We should say measure of angle A plus the measure of angle B is 90. And up here, if we call this angle A, B, and C, then the measure of angle A would have to be less than 90. Likewise, the measure of angle B would have to be less than 90. And the measure of angle C would have to be less than 90. All right. Obtuse, last one. This is a triangle with one angle greater. If I put a greater than symbol, it's going to look like that angle symbol. So let me go with one angle greater than 90. All right, so in this case, either A is greater than 90 or B, again, I should be writing the measure of angle B is greater than 90, or the measure of angle C is greater than 90. All right. And let me just talk through the proof with you. Given AD and CD are legs of isosceles triangles ADC and B is the midpoint, then how do we go about this? So let's mark up the information that we know from the diagram. I'll zoom in here. So AD and CD are legs. So these two, by definition, would have to be equal. B is the midpoint. Oh. I know that this side is equal to itself, so these two triangles are congruent. Yeah, if those two triangles are congruent, then those angles would have to be congruent by CP/CTC. All right, so this is a CP/CTC. We're going to use side, side, side in this proof, and we're going to use the reflexive and the definition. So here we go. One. We're given, no, yeah, we have an ABC, ADC. Triangle ADC is isosceles. Oh. I should use my zoom tool here. It's going to work better. And we are also given that B is the midpoint. So 1 AD would have to be equal to, congruent to, DC. And that is the definition of a isosceles triangle. Again, we're going to go to that old reflexive theorem. Something is equal to itself. And then we'll come over here and say line 4 is that the two triangles are congruent, right? We now have side, side, side. Oh, no, we don't. We're missing the bottom part. AB is congruent to BC. And that's the definition of a midpoint. Line 5, triangle ADB is congruent to triangle CDB. And that's the side, side, side postulate. 6, now by CPCTC, angle A is congruent to angle C because of corresponding parts of congruent triangles are congruent. All right, and obviously some algebra is going to come up. So if they give you a perimeter, we're going to show that this is scalene, so I got to show that this side and this side and this side are all different. So x plus 3 plus 3x plus 2 plus 2x plus 3 equals 20. I think I have 6 x's plus 6, 7, 8. Little Michael Jackson there in the background. So 6x equals 12. So x equals 2. And now we can go back in and find the length of each one. If x is 2, that's 5. 6 and 2 is 8. 4 is 7. All right. So therefore, it is scalene by definition. Hope that helps. Good luck in your homework.